Okay, let's begin. So, one of the strategies we talked about yesterday is reading the question. There's an idea. And maybe writing down things that you know. So an object starts at a position of -6. So we would call that like initial position, right? Oh, and it's -6. And ends up at a position of +10. So that would be the final position, which is 10. And what do we have to find? The displacement. Now, I can try. Delta D is equal to XF minus XI, final position minus initial position. I think I showed you that actually. It might even have been day 1 when we had the train going back and forth. XF minus XI. Don't get behind it. Here's the learning part. This is where you learn how to do it.
Last sheet. You have to find sheet away.
Yeah, I know, I do.
Way to go.
Okay. So, final minus initial. How much is the final? 10. How much is the initial? And I picked -6 for a reason, because you have to remember to subtract a negative. Exactly. All right, subtract that -6. So 10 minus -6 is going to be 16 meters. Use your units, equal signs lined up. Right? The displacement is 16 meters. Okay. We're going to take the next step now. We're going to take what we just learned, go to the next step. Object moves from a position of +10 to a position of -13 in 7 seconds. Find its displacement and find the average velocity during the trip. So the initial position is 10. The final position is -13. Which way is this thing moving? Kaylee, which way is it going, left or right? How do you know? What if that was -10? Still be going left? How do you know? Yeah, the -10 is going to -13. It's going towards the left, right? But it's not negative. Okay? And we need to find the displacement, delta D, and we need to find the average velocity, V bar. Delta D is XF minus XI. Delta D is going to be final -13. XI minus 10. Subtract +10. -23, right? And how do I find average velocity? Yep. Displacement over time. Line up your equal signs. Show your formula. Callan, are you getting this down here? -23 over the time, which is 7. 23 divided by 7 is like 3.2. Still pretty straightforward, right? And it would be negative. Well done, you guys. I made that mistake on purpose. You can tell because I never lie. Except at nighttime. Meters per second. Oh. Okay, here's another one. Find the time required to travel 150 kilometers at a rate of 80 kilometers per hour. Now, anytime you've got the question, you need to make sure that the units are kind of like equivalent or balanced, right? We've got 150 kilometers. We got 80 kilometers per hour. What if the kilometers per hour were in meters per second? times by 3.6. You got to have them both the same base unit, right? Fortunately, we don't have that. So we know the displacement. It's 150. We know the speed, the v bar, it's 80. We are asked to find the time. V bar equals d over t. 80 equals 150 over the time. And we did this yesterday. How do we solve for time? How do we solve for the unknown when it's on the bottom? Do the cross switcheroo thingy. $150 divided by 80? 1.875. How about we say 1.9 hours? 1.9 hours. Divide by 3.6 will give it to you in meters per second. Now, if I happen to need that 1.9 hours in minutes, how would I do that, Travis? If you happen to need it in minutes, how would I convert 1.9 hours to minutes? Divide by 60? Multiply by 60. Divide by 60? Multiply by 60? Multiply by 60 is correct. So it'd be like about 114. I was trying to pretend that I was doing it in my head. I just remembered it from this morning. All good so far? Noah, are we good? Yeah? Okay, so let's move on to like a sea level question. Smell that salt air. Ball rolls down a hill with uniform acceleration. What does that mean? Doesn't change, right, Connor? The acceleration remains the same throughout, constant. It starts from rest. Oh, no. Woo! So, a ball rolls down a hill with uniform acceleration. It starts from rest and rolls 28 meters in 4 seconds. Find the average velocity, final velocity, acceleration. It starts from rest. VI is 0. It rolls 28 meters. D is 28 in 4 seconds. Find the average velocity, V bar, the final velocity, VF, and the acceleration, which is A. This is going to be a few steps, isn't it? Okay, so the first thing we need to find is V bar. What formula do we know that has VI or D or T in it that solves for V bar? Yep. Delta D over T. 28 over 4, so the average velocity is 7 meters per second. Pretty straightforward. And here we go. We start talking about that that chart that we have. Remember when the initial was 0 and the average is 7. So what do you have to have for the final velocity? If the average is 7 and you start at 0, it would be, I heard it, 14. In a formula sort of standpoint, you would write V bar equals VI plus VF all over 2. Because how do you find the average of two things, Jared? How come 2? Because there's 2 of them. If you had 4 test marks, you'd add them up and divide by 4. Right? So the average velocity here is 7. See how I got those equal signs lined up? The VI was 0 plus VF over 2. Do I need the plus 0 thing there? No, so it's really VF over 2. And here's where some of that stuff comes into play that we did yesterday, right? Basic solving of equations that I've reviewed with you. You learned it in grade 9, so you need to be able to do it How do I solve that? Multiply both sides by 2. No, because it's already divided by. Right? You got to do the opposite. If Mom calls you to clean up your room, you
Clean it.
don't. Do the opposite. Not use that, right? Yeah, you follow. Yeah, absolutely. So, can I write the VF on the left-hand side?
No.
Why not? Does it matter if I write 14 equals VF or VF equals 14?
No.
No. And most people like the variable to be on the left.
Like most people?
Now, acceleration. Pens down. Do not write this.
I don't have a pen.
Pencil. Writing tool down. A equals delta V over delta T. Is VF the same as delta V?
No.
No, it's not. One is the final and one is the change. So how do I get the change in velocity? Change is going to be VF minus VI, right? Change in velocity, how much it changes is from the initial to the final, or final minus initial. So that's going to be 14 minus 0, which just happens to be 14. So when I said, is VF the same as delta V? Well, in this case, the numbers are the same. Will VF always be equal to delta V? Will VF always be equal to delta V? No? How come? Might not be 0. Exactly what else. That is only true, Braden, when VI is equal to 0. Only true when VI is 0. And eventually you'll get to the point where you just know that, and so you would just write underneath delta V equals 14 as well, right? Like, we know that subtracting 0 doesn't do anything, right? Okay. So now I'm going to go A equals delta V over delta T. So my delta V is 14. My delta T is 4. 14 divided by 4 is? And where's my answer? Final answer. Right there in the bottom right-hand corner where it's supposed to be. Are all my steps sort of separated? Are they in order? Have I shown my work? Have I written about as neat as I can? About as neat as I can.
Your R's look for your S look for your R.
How much do you think like something like that would how many marks do you think I would give you?
3.5.
100. Really?
That's what I feel.
1, 2, 3, 4.
Not 100.
Basically for the steps. Now I would probably offer some half marks along the way if there were some mistakes. But. Time for you guys to try one on your own. Oh yeah. Yeah, I've been building you up, pumping you full of confidence. Maybe I did that on purpose. An object that has an initial velocity of 1 meter per second, so VI is 1, reaches a final velocity of 12 meters per second 3 seconds later, so VF equals 12. 3 seconds later, T equals 3. Find the acceleration of the body during that time. You're looking for A equals delta V over delta T. Do we have delta V? We do not. So we got to find that first. VF minus VI. So that's going to be 12 minus 1, which is 11. Adam? A equals delta V over delta T. 11 over 3, and what do you get? 3.67, right? 3.7 meters per second squared. No, you guys need to learn how to round. It's 3.6 repeating. It's 3 rounds to 3.7. It's not. I don't see why you guys think that rounding is so hard.
Well, With 3.67.
Yes, I would take that. Okay. I'm gonna add one more question to this. I'm gonna add one more question to this because we got time. What is the displacement? What is the displacement? I will give you a hint. It's a country song. It's a two-step problem. What is the displacement? Go. Is that what you did first? You got to find the average first. What's the initial? What's the final? 1 plus 12 is? Divide by 2 is? Because that's not average. That's the change in velocity. Right? Average means add them together and divide by 2. Right? So that is our average speed.
Why are you so cheesy?
How do we solve this, Travis? How do we solve it, Travis? Come on, man. Take it home, brother. Multiply by 3, so you get?
Oh, God. 19.5. Let's go.
Is that what you had?
Yeah. She was doubting me the whole way.
There you go. I listened to the